So in our previous example, we saw how we can apply differentiation to get the maxima and minima. We also have another example here. This example the diagram below shows a cone of radius A and height h, cone radius A, height h, okay, in which a cylinder of radius x, this is the cylinder, is inscribed. It is inside of the cone. Part A, express the height h prime, this one here, of the cylinder in terms of x, a, and h. Let us start off with this one here. I want us to express this h prime in terms of h, x, and a. Now, how would we do this number? We are going to first of all consider using similar figures. When we look at the cone in relation to the cylinder, they produce two cones. So the first cone is this upper one coming from here. I can extract it out just. This is the first cone. Then we also have another cone that is the original cone of the question, this one here. That's also a cone there. I can also extract out the shape like that. That's our other cone. Now we are going to put the dimensions before we compare. So the height of this bigger cone is h. This is h. Then its radius is a. Radius of the bigger cone is a. Then when we come to the smaller cone, the radius of the smaller cone, since this is x, also this is x. So the radius of this smaller cone is going to be x. Then the height of this smaller cone is going to be the difference, because from here to the top it is h. Then from just here to the top we have nothing. So for us to be in position to get this remaining part here, we are simply going to get h, we subtract off h prime, such that this one is height is going to be h minus h prime. Now we are using similar figures. So we are going to say the radius of the smaller cone divided by radius of the bigger cone is equal to the, let me say, radius of the smaller cone divided by radius of the bigger cone. This is equal to the height of the smaller cone. I start with s, also this is supposed to be s, then divided by the radius of the big cone. Sorry, this is by the height of the big cone. Radius one side, h one side, but the sizes should be corresponding. So the radius of the smaller cone is x divided by the radius of the bigger cone is a. This one is equal to the height of the smaller cone is h minus h prime, and this is what we want to make the subject, h prime. The whole of this is divided by height of the bigger cone, which is h. Now when you cross multiply, we shall have, this is what we want to make the subject, remember, it is h prime we want to make the subject. When you cross multiply, we shall have h times x being equal to a into h minus h prime. I want to make this the subject, so I can divide through by a. I have it as hx over a is equal to h minus h prime. When the h prime crosses, it becomes a positive. H stays. When this one crosses, it becomes a negative, which I can rewrite as, get LCM, which is a. I have it as ah minus hx. So I can conclude and say that therefore h prime is given by h over a into a minus x. So therefore part A is done. H prime is given by this. I'm going to write it somewhere up here. I might need it for another part B. I can write it and say that my h prime is given by h over a into a minus x. Now I can happily take this off. I go to another part. Part B says, show that v prime is equal to 4 over 9v, where v prime is the greatest volume. Now we are looking at maxima and minima. In this case, they have used the word greatest. Another word they can use is least to show that they want you to apply differentiation in maxima and minimum. So in case they say least area, least volume, greatest volume, they are meaning the same thing, maxima and minima. So it means that we have to differentiate some at some point. So they have said that show that v prime is equal to 4 over 9v, where v prime is the greatest volume of the cylinder. So we start by getting the volume of the cylinder. Let me say volume of the cylinder is given by pi r squared h. This is the actual volume of the cylinder, but in this case, our volume of the cylinder is given by pi is a constant, r, radius of the cylinder is x, so I have it as x squared, then times h, the height of the cylinder is h prime. But in this case, okay, we can write it like this, such that v is equal to pi x squared, then h prime is what we got there as h over a into a minus x. This is what we have. Now I can open brackets. I have it as v is equal to, this is pi x squared times h, then times a. Then the whole of this I'm having it divided by a. Then I also open brackets. I have it as, it is going to be minus pi x, this is going to be x cubed, this x and this. Then I have h over a. So meaning that my volume is given by pi x squared h, the a cancels, minus pi x cubed h over a. Now in this equation that I have, the a is a constant because it is any value we shall have. But in what we have as the volume of the cylinder, the only representative we have in our equation is x. The h is for a cone. The a still is for the big cone, the radius of the big cone, and the h is for the big cone. So this means that if you are to differentiate, you are going to differentiate with the radius of the cylinder, because they say v prime is the greatest volume of the cylinder. So what values of a cylinder in this expression is x. So it means that here we shall differentiate with respect to x, because x is directly attached to the cylinder, not the h, which is for the cone. So when we get divide x, we shall have 2x, then pi h. This is minus. When we differentiate this, we shall have 3x squared pi h over a. A and h are staying as constants because they are not concerned with the cylinder. For them, they are for this cone, so they remain constant. But we know that for greatest volume, we say that our dv, the x, is equal to 0. So we shall substitute and say 0 is equal to 2x pi h minus 3x squared. This is pi h over a. I can see the pi h cancels out. Then when I also one x is going to cancel. So when I bring this side, it will have to be 3x is equal to 2a. But in this case, I need to substitute for, okay, we can write it as x being equal to 2a over 3, or we can make it a subject n that you're comfortable with. this is what we shall have, 2a, yeah. So we are saying that our value of x is given by 2a over 3 from this expression here. From this expression, I think that's what we have. But we are going to go and substitute back for us to get the greatest volume. So we are going to say now V prime is given by the volume of a cylinder is this. But for it to have a maximum value, x must be equal to 2a over 3. So this is going to be 2a over 3. I square it, then I multiply it with h prime, which I can write as, I have the value of h prime as h, let me open brackets there. This is ha minus hx. The whole of this is over, sorry for this. Let me just substitute the whole of that once. We have it as h over a, then a, which is a, then minus x. Our value of x is 2a over 3. Now v prime is going to be equal to, I have 4a squared over, this is a 9, then I am multiplying it with, I have h, that is common, h over a. This is 1 minus 2 over 3, which is 1 over 3. 1 over 3. But we have a in the numerator, a over 3. So this a cancels with that a, and our v prime that we have established now becomes 4. We have a squared h over 3 times 9 is 27. 3 times 9 is 27. So this is what we have got. Now, there is something they talked about comparing v prime and v. They said that can be inscribed in a given cone of volume v. So we are going to get volume of a cone. This was a cylinder that is inscribed within. Now we can get the volume of a cone. How do you get volume of a cone? Volume of a cone is given by the base area, which is pi r squared, times the height, which is h. In this case, we have pi is a constant, r squared of a cone is a, so we have to write it as a squared. Then h is the height of the cone, which we can leave as h. Since this is h, also this is h, we can leave them. Now, when I reach here, I can combine these two. How can I combine the two? If, for example, this is equation 1 and this is equation 2, I can choose to say equation 1 divided by equation 2, such that I have it as equation 1 divided by equation 2. I'll come up with equation 1, which is v prime over v is equal to, the value of v prime is 4a squared h. The whole of this is divided by 27, but we are saying this is divided by our v, and our v is a third into pi a squared h. So we shall have v prime over v being equal to 4a squared h over 27 times, we get the reciprocal. This one becomes, I think we forgot a pi somewhere. There is this pi here. There is this pi we forgot. Yeah, there is a pi. 4 pi a squared. Then times 3 pi a squared h. We are getting the reciprocal. Sorry. We get the reciprocal of this. It is a 3 over pi a squared h. Now, after reaching here, we have the pi a squared h cancelling. Then we have by 3, 1 by 3, 9. So we have v prime over v being equal to 4 over 9. Then we can cross multiply we can multiply both sides by the v and we see if we get what they want. So v prime is equal to 4 over 9v. And actually this is what we are proving. Hence, proved as required. So this is what we have. See you in the next example, still on maxima and minima.